And the medical component, the medical considerations become extremely important, perhaps paramount to such a trip.
So I think space colonization, even though I'm all for it, is going to be longer term than we thought. Because, well, first of all, we have to leave the Earth. The Earth in 5 billion years will be destroyed.
It all started with a documentary that made a bold claim. The moon landings by American astronauts never happened. They were all a big, elaborate hoax filmed in a studio. That's quite a conspiracy theory, right? But there's so much more to the moon than meets the eye, especially its mysterious far side. Plus, there's information hidden by the authorities about this lesser-known side of the moon. But here's where it gets interesting. A Soviet-era cosmonaut is breaking the silence and revealing details about a secret mission to the far side of the moon. So, what's the deal with the far side of the moon? Well, let's start by understanding that the moon is quite unique. You see, it's tidally locked to Earth, meaning one side always faces us, and the other side, the far side, remains hidden. But it's not dark in the sense of lacking sunlight. It's just less known to us. In fact, only about 18% of the far side is occasionally visible from Earth due to some wobbling. The remaining 82% remained hidden until 1959, when the Soviet Luna 3 space probe photographed it. The Soviet Academy of Sciences even published the first atlas of the far side in 1960. But let's fast forward a bit. The Apollo 8 astronauts were the first humans to see the far side in person in 1968. Before that, all lunar landings happened on the near side of the moon. That changed on January 3, 2019, when China's Chang'e 4 spacecraft made the first ever landing on the far side.
It's only 3 days into the new year and China is already making history. China's Xinhua News Agency has reported that the country's Chang'e 4 lunar probe has just landed on the far side of the moon.
This side of the moon is a rugged place with lots of craters and not many flat, dark lunar maria or seas. Now you might wonder, why the far side? Well, astronomers have a great idea. They want to set up a huge radio telescope there. The moon can shield it from radio interference from Earth because of its tidal locking with our planet. But you might wonder why we never see the far side from Earth. Well, this is because of that whole tidal locking thing. The moon spins on its axis, but it takes the same amount of time to complete one rotation as it does to orbit Earth. So we always see the same face. If it rotated faster, we'd eventually see all sides of it. Now, let's talk about some of the cool missions and discoveries related to the moon. One fascinating spacecraft is the Lunar Reconnaissance Orbiter, LRO, launched by NASA in June 2009. It's been orbiting the moon ever since, collecting all sorts of high-resolution images and data. The LRO has been a game-changer in our understanding of the moon. It created a detailed 3D map of the moon's surface, helping us identify safe landing sites and potential resources for future lunar missions. It's like Google Maps for the moon. But that's not all. The LRO has taken ultra-high-resolution pictures of the landing sites of various lunar missions, including the Apollo landings and Soviet missions like Luna and Lunokhod. These images show the footprints, tracks, and instruments left behind by previous lunar explorers. It's like a historical record of our visits to the moon. The LRO's measurements are so accurate that it managed to find the long-lost Luna 1 rover and its retro-reflector, which had stopped responding in 1971. That's like discovering your old, forgotten toys in the attic. Now here's something pretty mind-blowing. The LRO has found evidence of water ice on the moon, which is a huge deal for future lunar exploration. The LRO found water ice in some permanently shadowed craters near the moon's poles. These craters are so deep and cold that they never receive direct sunlight, so they can preserve water ice for a very, very long time. The water ice on the moon is a big deal for future lunar missions. You see, water can be used for drinking, farming, producing oxygen, and making rocket fuel. The LRO has also delved into the moon's volcanic history. One interesting discovery is that some of these volcanic features are much younger than we initially thought. It suggests that the moon was volcanically active for a more extended period than previously believed. Now let's talk about something super exciting. China's Chang'e 4 mission is the first and only human mission to land and explore the far side of the moon. Chang'e 4 consists of a lander, a rover named Yutu-2, or Jade Rabbit 2, and a relay satellite named Qiqiao. The mission was launched on December 8, 2018, and entered lunar orbit on December 12, 2018. The lander and rover touched down on January 3, 2019, in the Von Karman crater, located in the South Pole Aitken Basin. Now, the South Pole Aitken Basin is a big deal. It's the largest and oldest impact crater in the solar system, about 2,500 kilometers in diameter and 13 kilometers deep. It's thought to have formed around 4 billion years ago, when a massive asteroid smacked into the moon. This impact might have exposed some of the moon's mantle material, providing clues about the moon's history and evolution. Chang'e 4 is investigating the geomorphology, mineral composition, and shallow subsurface structure of the landing and roving sites using various cameras and spectrometers. These instruments capture high-resolution images and spectra of the lunar surface, revealing different types of rocks and minerals. Chang'e 4 also grew plants in a sealed container on the moon. This was part of a biosphere experiment to test the feasibility of creating a self-sustaining environment on the moon. The experiment contained soil, water, air, nutrients, and seeds of cotton, potato, and thale cress, a flowering plant. It also had yeast and fruit fly eggs to create a simple food chain. But there's a twist in the story. The lunar night, which lasts about 2 weeks, brought extremely low temperatures that killed the plants and other organisms. The container wasn't designed to withstand such conditions. Despite its short duration, the experiment was a massive success and opened up new possibilities for future missions aimed at establishing long-term human habitation on the moon or other planets. And here's a real gem of a discovery. Chang'e 4 found a new type of volcanic rock on the moon. The rover used a spectrometer to analyze the reflected light from different minerals on the surface and found 2 patches of rocks rich in olivine and low calcium pyroxene. These minerals aren't common in the lunar crust, but are expected to be abundant in the lunar mantle, the layer below the crust. The lunar mantle is largely inaccessible as it's buried beneath a thick layer of basaltic lava. However, some scientists believe that large impact events might have exposed some mantle material, and Chang'e 4's discovery could be evidence of this process. Chang'e 4's landing site is also fascinating because it's in a region much younger than the areas visited by previous missions. The lava flows in this area date back to about 2 billion years ago, which suggests that the moon was still volcanically active much longer than we thought. This hints at regional variations in the moon's volcanic history, challenging our understanding of how and when lunar volcanism occurred. But let's not forget about the Soviets, who made their mark on lunar exploration. The Soviet Union was the first to capture images of the moon's far side using the Luna 3 probe. It was a groundbreaking mission that unveiled the hidden face of the moon for the first time in human history. Luna 3 was launched on October 4, 1959, and it had a special mission: to fly around the moon and photograph its far side. This was a big deal because no one had ever seen this side before. The probe had to be clever in its design. Luna 3 was like a canister with cameras and instruments. It had solar cells for power, antennas for communication, and scientific instruments for measuring things like cosmic rays and micrometeoroids. But the star of the show was the Yi-2 camera system, which included 2 cameras, a film processing unit, and a scanner. The cameras could take pictures with wide-angle and close-up lenses. The film processing unit developed and dried the film automatically. The scanner converted the film into electric signals for transmission to Earth. So, on October 6, 1959, Luna 3 reached the moon and began taking pictures. It completed its mission, capturing 29 pictures that covered about 70% of the far side surface. These pictures were sent back to Earth between October 7th and October 18th, 1959. Now the pictures weren't perfect. They had noise, distortion, interference, and low resolution. But they were still good enough to reveal that the far side of the moon looked very different from the side we're used to. It had fewer Maria and more craters and mountains. Luna 3's images caused quite a stir and fueled interest in lunar exploration. They challenged what we knew about the moon's geology and history. The Soviet scientists even published an atlas of the far side of the moon in 1960. Based on improved image processing techniques, They named many features using Russian or space-related names. The Luna 3 mission showed that the moon had a lot more to offer than we initially thought. It was a historic achievement that set the stage for future lunar exploration, and we can't forget about the Luna 17 mission, which carried the Lunokhod 1 rover to the moon. Luna 17 was launched on November 10, 1970, and it delivered the rover to the lunar surface on the Sea of Rains, a flat area on the moon. Lunokhod 1 was a true explorer. It was equipped with 4 television cameras, an X-ray spectrometer, an X-ray telescope, cosmic ray detectors, and a laser retroreflector provided by France. It even had devices to test the lunar soil's density and mechanical properties. It was like a rover with a Swiss Army knife of scientific instruments. The mission was initially planned to operate for 3 lunar days, about 3 Earth months. But guess what? It exceeded expectations and kept on going for 11 lunar days, about 11 Earth months. It covered a total distance of 10.54 kilometers during its journey. Lunokhod 1 not only transmitted 20,000 TV images, but more than 200 TV panoramas and over 500 soil tests, and more than 140 lunar soil samples. It also measured the moon's magnetic field, detected cosmic rays and solar wind particles, and reflected laser beams back to Earth. But all good things must come to an end, and Lunokhod 1's mission concluded on September 14, 1971, when it lost contact with Earth. Its last image showed its own shadow on the lunar surface. From the groundbreaking Luna 3 mission of the Soviet Union to China's Chang'e 4 and its remarkable discoveries, lunar exploration has come a long way in shedding light on the moon's hidden side.